Hi everyone, and welcome to the 8th webinar in the AWC3's webinar series about watercourse crossings. So my name is Daniel Monaco and I'll be acting as your host for today's webinar. So before getting into today's webinar, I just wanted to give a brief introduction to AWC3 in case this is your first webinar in the series. So AWC3, Alberta Watercourse Crossing Collaborative, is a non-for-profit organization whose primary objective is to facilitate information transfer around the issue of watercourse crossings in Alberta and their impact on native fish species. So this is what this webinar series is all about, is sharing that information from subject matter experts and trying to get that information out to as many people as possible. Since we have received some questions about this, I want to let everybody know that this webinar can be used for continuing competency credits for professional associations. So it counts for a half hour of credits and has been approved by most major professional associations. So if that's something you're hoping to take advantage of, make sure to keep your receipts and your registration confirmation emails. And if you have any questions about that, you can email us at info@awccc.ca and we'll get back to you as quick as we can. I guess just a side note here, I want to apologize to everybody for some technical issues last time. So due to some technical issues, we actually, the timing was set up wrong on the GoToWebinar page. So the webinar actually took place at 1 o'clock, but the scheduling said 2 o'clock, so many people missed it. So I apologize if that was the case for you. And I'm hoping that you're able to access the recording and get any questions to us that you may have had. So today's webinar is about using terrestrial LiDAR for watercourse crossing management, and we have Javed Iqbal from Alberta Agriculture and Forestry with us as a presenter. So to give a bit of a background on him, so Dr. Javed Iqbal has over 14 years of natural resource management, field research, and data analysis experience in a number of countries throughout the world. He specializes in GIS applications, analysis, and modeling in a wide range of hydrological, forest, and ecosystem values. For his doctorate, he focused on developing a GIS-based decision support system for forest pest management with extensive work involving spatial analysis, landscape ecology, and forest estate modeling. He has over a decade of experience working directly with watercourse crossing management and is now working for Alberta Agriculture and Forestry. So before passing things on to Javed, if anyone has questions throughout the presentation, you can submit those through the GoToWebinar program. So on that control panel on the right-hand side of your screen. So I will be compiling all the questions as they arise throughout the presentation, and we'll get to those once the presentation is done. So the presentation should take about 25 to 30 minutes, and then we'll have about half an hour of Q&A. So I would ask that anyone asking questions, that those questions pertain directly to the topic of the presentation so that our presenter can answer those to the best of his abilities. So without further ado, I'll pass things off to Javed.
Thank you, Daniel. Thank you all for joining in and attending this webinar about the newer technologies, especially terrestrial LiDAR in watercourse crossing management. I call this as adding the third dimension to your stream crossing assessment. So I know Daniel has given a short intro of myself, just to add a couple of points and to get things into perspective for this topic. I would say I just love technology. Though forestry is my background, I have been self-learning GIS, spatial analysis, data sciences for decades now. I have been very keen working with the 3D analysis and visualizations. I have been an active participant on the stream crossing inventory program from back 2012-2013 when it was initially initiated and helped build on the technical side before joining the government. And I would say I feel confident on saying that I have no hesitation in jumping in and testing new technologies. You sometimes learn the hard way while doing things like that, but I guess this is where the fun lies. So to give you an outline, I will try to cover the topic on a more basic to an intermediate level. We will try to justify the use of LiDAR, or I guess rightly saying the more use of LiDAR. We will jump in to discuss some dry theory that will lead us into the use of terrestrial LiDAR into other resource management areas. As we all inspire from other uses, we will discuss the use of terrestrial LiDAR in watercourse crossing management. I know there will be lots of questions later on the limitations of terrestrial LiDAR, and I will try to address few of those upfront next. We will then close off with the summary and Q&A. So we must all recognize this by now. Yes, it's COVID. Besides all the devastation, one thing is for sure. It has changed the world. It will change the way we live and work. What it means is that the world will be driven more by technology. We will have all these presentations in person in a nice workshop conference scenario or environment, but we are doing it through webinar. This is all the way it was planned was through an in-person presentation in a conference, but due to COVID, it had to be changed. Another important thing to note is that almost all of us are measuring something daily. As Peter Drucker, an Austrian-born American management consultant, an educator and author, once described as the founder of the modern management, rightly said, what gets measured gets managed. What it means all going into the future is that for most businesses, there will be we will have fewer bodies that are going to a site and managing it, either it be inventorying, doing a survey, or even involved in construction or other management activities. There will be higher need of cost reduction and being more efficient. We will have less crew going to the site, probably fewer times, and the expectation will be to bring all the required data that is essential for that particular project. It also means that we can no longer just plan a trip to a remote site just because we are bored in the office. Now, the expectation would be to bring correct and more detailed data in one go. Now, for me, all of these ties back to LiDAR. So before starting off, I would like to post a poll there. Daniel, can you please help me out with posting this question?
Yep, I'll just launch it right away. Give people about 30 seconds to answer. All right, close that. We'll just share the results. I know you can't see that, Javed. So 52% of people said that they have used LiDAR data, and 41% have only heard the acronym, and then 3% for the other two options.
Thanks, Daniel. So I'll show my one. Okay, so yeah, that 42 number is a big number, so we can definitely start with some introduction and some light detection and ranging, which is the actual name for LiDAR. Now, it's an optical remote sensing technique that uses laser light to produce high accuracy X, Y, and Z measurements. These X, Y, and Z measurements are dependent upon a particular reference, as in Cartesian coordinate system, or can be broadened up to a certain geographical coordinate system. This method is not new. It was originally it started off in 1960s with the invention of the laser, whereas the first commercial airborne LiDAR system was developed back in 1995. Now, LiDAR is an active remote sensing technique where a target is eliminated with the laser. This is usually done through a transmitter on a sensor and analyzing the reflected light, which is done by a receiver on the device. So a LiDAR equipment is, in most basic case, consisted of two components, a transmitter and a receiver. Now the transmitter generates an optical pulse towards an object, and the pulse is reflected back and returned to the receiver. This return beam or pulse is collected and processed to obtain property of the target. Now, receiver accurately measures the time interval, and based on the wavelength and the time, the distance is accurately measured. Now, if you go back to our justification there of measuring or collecting data from a distance. Now, what LiDAR provide us is a higher resolution and more accurate data. It is less weather dependent. You can do it at night time even, which is it has the ability to generate precisely a georeference spatial information about the target, and has the power of being a 3D documentation of the target that can be later accessed for computation of other parameters without personally revisiting the sites and objects. Now, there are two basic types of LiDAR, the aerial and terrestrial. Though there is a third type, which is the satellite or spaceborne, which covers large area mostly for meteorological purposes. The industry in general uses these two types. The aerial LiDAR has been in business for the last almost 20 years there, and most of us are familiar with it. These are of basically two types. The one which is used for land, that is topographic, and those on water bodies, that is for bathymetric. The main difference in the two is based on the frequencies on board the transmitter. So infrared wavelengths, which are about 1500 to 2000 nanometers, are used for meteorological applications. Near infrared, which is about 1040 to 1060 nanometer, are used for the terrestrial mapping, whereas the blue-green with a frequency of 500 to 600 nanometers, or a wavelength of that much, is used for the bathymetric applications. In the last 4 to 5 years, drone-mounted LiDAR has been developed and has been used commercially. They are very promising, I would say, but it still have a lot of noise and data limitations that needs to be cleaned out. I guess they'll be actively developed by the vendors in near future. But the aerial LiDAR using helicopters or fixed-wing large planes is quite mature. Now, the terrestrial LiDAR is essentially of two types, a mobile and a static. I'm not sure how many of you remember or have watched the TV serial back from 80s, The Knight Rider, with a super self-driving car named Kit. Now, the crazy race of self-driving cars nowadays using mobile terrestrial LiDAR to know its surrounding is out there. It has been used to map linear features like roads and railway tracks. Small portable mobile handheld and backpack versions of the mobile terrestrial LiDAR are also out there and used commercially. I would say in terms of application, some extremely neat stuff has been done by DARPA, which is the Defense Advanced Research Project Agency. The project itself is called DARPA Legged Squad Support System, or LS3. If you search YouTube for DARPA Mule, you will find it, and it's really interesting. Okay, no more shiny squirrel. I'll try to stay back onto my topic. The other type of terrestrial LiDAR is the static, which we are going to talk a bit more. The picture is me with a Faro X330 scanner, excuse me, on a seismic line trying to capture the vegetation condition before and after a linear restoration project, which is that one. Sorry about that. Okay, so going forward, last Thursday, Ian Sharp talked about drones and point cloud generating using the photo triangulation method in a AWC3 webinar. The XYZ data or the point cloud data generated from that method looks similar to the one generated by a true LiDAR. Now, but there are some subtle differences in that. The main difference is the terrain modeling under the vegetation. That is not possible through photo triangulation. The difference are more apparent on project by project or case by case basis, as well as the type of sensor used on both type of platforms. One important consideration is the operational aspect of it. This includes both size of the project, cost, and level of accuracy is required. It goes back to Ian's comments of knowing the objective of your mission and picking the right tool for your final deliverables. There's a lot more to consider in order to choose what works best for a particular project. As I usually say, there is no good or bad for a particular technology. It's just ugly when when you pick the wrong tool for the question asked. Now, in terms of terrestrial LiDAR, there are many vendors out there. I would say it's truly very hard to choose. It basically comes down to what works best for a particular use. Some are very specific to a survey application, some are easy to use, some uses long range versus short range, some are more costly than the other, some are more complicated or compatible. Some are more compatible with broader solutions like Autodesk, FME, and Esri. But the main principle, as discussed on the previous slide, is the same. All are capable of recording hundreds and thousands of points with more accurate location and captures the intensity and RGB value of that point. They all are fairly comparable in terms of their relative positioning and their millimeter accuracy. Now, in a sense, if there is an adage, a picture worth 1,000 words, I personally believe a 3D picture would most definitely worth 1,000,000 words. Now, in terms of their use in other resource management areas, we talked about the autonomous vehicle, which uses terrestrial LiDAR for obstacle detection and avoidance and to navigate safely. So so stay tuned. We all can have soon own kit like Mike car that is on the Knight Rider serial there. There has been a number of recent applications for reconstruction of the accident and crime scenes using terrestrial LiDAR. The old method of taking thousands of pictures in the forensics is fast going away. Another application is in the geological and the soil science world there. ICESat-2 was launched by NASA back in September 2018 for measuring the ice sheet elevation, sea ice thickness, as well as land topography, vegetation characteristic, and clouds. Now, there has been an increase in using LiDAR for agricultural applications, like in precision farming. It's used to identify microsites with different sun exposure and evapotranspiration rates. Now, forestry has by far been the leader in the natural resource management application of LiDAR. There has been numerous studies to replace permanent sample plot measurements or PSP measurements from traditional tape and caliper measurements to this method. Here is a picture of a PSP near Sunray. Now, the terrestrial LiDAR scanning was done, and many of the permanent sample plots parameters like the DBH, height, stem counts, etc., can be easily extracted from the 3D data. Now, I'm going to play a video of FP Innovations that has funded my studies back in New Brunswick when I was studying there, and it provides a good depiction of what we have talked so far. Okay, so there are many applications in the civil engineering side for the BIM, which is the business building information modeling, and all of these tools are very smooth and integrated with Autodesk solutions, more specifically with the Autodesk Revit. Now, 3D printers are very common nowadays. Scanning a particular part, creating the STL or OBJ files for printing from a laser scanner is common. Astronauts are printing their required nuts and bolts out there in space using the LiDAR scanner and a 3D printer. Now, keeping a 3D documentation of an asset and checking the faults is another application of LiDAR scanners. Here is a here is a short video of a scan done in minus 28 degrees centigrade just off Anthony Henday on 111 Street in Edmonton using a Faro X330 scanner. The shiny little object that you see in the back between the two poles is my old faithful van there. The rendered video is of the point cloud. So you can measure distance between any 2 points because each point have got an X, Y, and Z value associated with it. You'll be amazed with the level of details from just one 9-minute scan done from the ground. Now, other applications that I have been involved with is in restoration of linear features like seismic lines. One can do a pre and post reclamation change detection using terrestrial LiDAR. Now you can see a Faro X330 scanner on the seismic line in this particular picture. Here is just the RGB of a GIF using a 3D from the 3D data sets, and you can pretty much measure or count trees and do other measurements within this 3D image. Here is the point cloud again for the same site. Calculations can be done using the XYZ properties of each point. So it's a neat stuff. You can do a lot more from the single scan. Here's another application that we tried in a timber yard to measure the trees and the volumes there. Now, talking about all of the other applications, coming to the terrestrial LiDAR application in watercourse crossings. 3D documentation of bridges is fairly common. Many old historic bridges have been scanned for historical documentation. It's a great tool for large crossings and for large restoration projects. It has a limitation though on small projects where the crossing has been hindered by vegetation. A very important point to mention here is that it captures information the human eye can miss. Human eye can miss important information, especially in inspection scenarios. Now, the scan data gives you means of going back in an office environment and process the information without human subjectivity. It also provides a permanent record to your inspection. Talking about crossings there, this is an open crossing, an imagery that was taken from a drone. And for a similar kind of crossing, it will be very easy to use the terrestrial LiDAR to do a more detailed scan. But there are some limitations on a crossing which have a lot of vegetation surrounding it. Now I'm going to show you a video here. I'll just play it now. It's a crossing on Virginia Hills 17 kilometer with a large hanging pipe that was restored by Miller Weston in 2018. Now, I would like you to note the side view of the road and the side profile that shows the planer to see a complete profile, including the water processing intake, the output, and the entire scour pool, and all of the volume in between that can be measured for digging and other earthworks. Okay, sorry for the very thrilling music there. Now, just like drone, the surface model create using the terrestrial LiDAR can be used for volumetric estimates, like in this case. If there is another view, and we can certainly do some volumetric estimates for your other construction needs. All the essential parameters like culvert diameter, outlet gap, etc., can be calculated from the data sets, and that can be done in your office. A white sphere shown in the culvert here is used for referencing and for stitching multiple scans. As one can see, you can estimate the culvert length as well as the backwater proportion more accurately than the visual estimates. I guess there will be quite a few, not that many people who will go and crawl into this large pipe and estimate that. Here is another RGB image. Since you can orient yourself in the 3D image, you can have a better estimate of sedimentation and other parameters that are important. Now, talking about the bridge inventories, LiDAR can be used to supplement bridge inventory work, safety and infrastructure inventory, as well as assessments. Now, in most jurisdictions, a triannual inspections is needed by the engineer, and one in every 3 years, and an engineer tech has to go out and do it every year in between. Now, a technician who have got a terrestrial LiDAR can go and do multiple bridges in a day and can view it, the exact details back in the office settings. It also provides a permanent record for your infrastructure. Here is another video of a Marsh Head Creek crossing, which is just west of Whitecoat. Now there are about 800 million points in that one rendering image. So you can estimate the extent of a project from using a terrestrial LiDAR. Now that take us to the limitations here. Since we are dealing with millions of points for even small project, there are very specific hardware and software requirements in order to process large data sets. Most of these softwares and data processing is extremely heavy on RAM. I once had a 120 gigabytes of RAM computer that I call Tank. Similarly, each scanner type will have their own software and processing datasets algorithms. Some of the videos that you saw had seen scrolling through. This is the software that is used by the Faro scanners. There are hundreds of proprietary file formats that you would be battling with if you are working with the terrestrial LiDAR files. These files they have extensions like .ploi, .las, .lidata, .e57 formats, etc. It will take some time to get through and to know and how to work with them. Challenging, but I would say very interesting too. Now, I would also like to emphasize the fact that the computation power and the softwares are updated by the vendor very frequently. Processing limitations now are not as severe as they were 5 years ago. One has to keep themselves technically updated. Now, the processing time would also vary. Essentially, as like any other project there, the larger the project, the more resource intensive it is and will consume more time. The problem here with the terrestrial LiDAR dataset is that the limitation would increase exponentially. Best to capture what is required instead of going for the highest resolution setting. Recent advancements in the cloud computing has greatly reduced the requirement for buying a supercomputer like Tank upfront. You can rent one on platform like Azure or on AWS, which is the Amazon Web Services, with almost no capital cost upfront. Let's review what we discussed today. We are in a changing world with the pace that is at a different level because of COVID. We need to adapt and adapt fast. There is a need for more and more data that is more accurate and more detailed. Data that you can take and interact with and answer questions that were not asked at the time of data collection. Be more efficient and be more cost effective. LiDAR in any format provides means of 3D documentation that can be used for better planning and management of resources. It has been used in many applications, with some reaching to the level of industry standards. There is a potential of it being used in water course crossing management. There are technical and cost limitations associated and cannot be ignored, but keep yourself updated would be the key. Now, the best is to know the objectives of your project and set a good technology for it that will bring most efficiencies, and while you know your limitations. LiDAR scanner should be one other tool in your belt and should be used where feasible. With that, I would like to thank you all for attending the presentation, and I can take questions from here.
Thank you, Javed, for that presentation. Just before we get into the questions, we're just going to do a quick poll to see where everybody's affiliations lie. I only see one question that has come in so far, so if anybody has questions to ask, please submit them now. This will give you a little bit of time to type those out. So I'll launch that. We'll give everyone about 30 seconds to a minute. Okay, let's close that. Just to look at that spread. So as we expected, this has been the case throughout all of the webinars so far, but 46% consulting. So good to know that that's where everybody's coming from. All right, so we'll jump right into the questions now. So Javed, the first question that we have is a two-part question. So how long does it take to complete a scan of a basic culvert crossing site? So how many hours would that take? And what is the data processing time for one crossing to create a 3D model and to determine your cut and fill volumes?
Okay, it's a very good question there. Now, in terms of how long does it take to complete a scan on a basic culvert, one scan, it depends on project. The larger the project, you will read more scans. You need to cover the area so that there is no shadows left. Shadows in terms of whenever you make a scan, there will be an obstacle, and behind that obstacle you cannot see what the point cloud would look like, and you would like to reduce the amount of shadow on a particular project so that you pretty much cover the whole area. So the larger the area, you will need more scans. The smaller the area, you will need fewer scans. One individual scan would range from about 4 minutes to about 27 minutes. 27 minutes is very detailed, dense cloud. 4 minutes one is a small scan that will have fewer points. So it depends on what resolution you want to keep. It depends on the size of the project. Now, to give you a ballpark number, it would take the video that you saw for a crossing that was restored later on by Miller Western. It had 9 scans, and it would take about 2 hours roughly for doing the whole scan. That includes the setting up the equipment and running with it. Now, in terms of data processing time, it would take a day to process a basic culvert for its 3D model as well as cut and fill volumes there. Most of the softwares that comes with the scanner have the ability to do it on the fly, and there are many optimizations that you can bring in. So you can bring your scans into your software and let it run overnight. In the morning when you wake up, you will have it all stitched up. You don't have to sit in front of it while it's doing the processing. And then from there to determine the cut fill volumes is about an hour job for you. Hope that have answered the question.
Thank you, Javed. I think it did. So the next question on the list, do you have any insight on the use of terrestrial LiDAR on the evaluation and measurement of non-woody vegetation? So this person is curious about its use in the application of pipeline post-construction in an agricultural setting.
Yeah, it's a neat application for sure, to have it for the coarse non-woody debris or non-woody vegetation. It is possible. I haven't came across a large-scale application of it though. There are many other means of doing it more effectively or efficiently, but it's definitely possible. I have tried scanning a timber yard for similar purposes, or you can go and scan a pile of dirt to determine the volumetric estimates from there. Pretty much a similar kind of application. I also went out and did one dam estimate, so scanned a dam to determine how much water it can hold. So there are multiple applications. Again, it depends on the project, on the scale and extent of the area. The more obvious, more open it is, the easier it is to do a terrestrial scan on those applications.
Okay, thank you, Javed. So the next question is, can terrestrial LiDAR conduct bathymetry of a crossing site?
The short answer is no. Most of the scanners out there, the terrestrial LiDAR scanners, are not using the bathymetric wavelength, and hence those cannot be used. But if you have a different scanner that you bring into your terrestrial settings and do some customization, yes, you can do that.
Okay, thank you. So what is the cost to get into entry-level LiDAR equipment?
It's a very good question. One of the slide I did mention that it's a very hard decision in terms of selecting the range of LiDAR there. It totally depends on your application. Some LiDAR equipment are very expensive. Some are very cheap. The ones which are in handheld and you can take it into a for example into a cave and model that out, a 3D model of a cave. Those are fairly cheap. There are some which have been by ESIRO down in Australia, the Zebedee it's called. They are cheap. Like cheap means in a sense like you can come down all the way to a couple of $100 there. But then there are some which are fairly expensive within one company, for example, Leica or from Frero or others. They have a range of different products too. So one would have a lesser range, a few 100 meters or a couple of meters even in some cases, versus some which have hundreds of meters of range there. So you can do large bridges while scanning large bridges while sitting on the shore. So it depends on the larger the range, the more expensive it is. The more functionality have, the more expensive it is. So the cost is really dependent on the type of LiDAR, and it may vary from a couple of $100 to easily to about $150,000 to $200,000.
Thanks, Javed. Forgot to unmute myself for a second there. Next question. Would you consider the review of 3D scan data comparable to an engineer's visual assessment of in the field?
The short answer is yes. If you have asked these questions about 4 or 5 years ago, the answer would have been a no or maybe. But right now, there are industrial standards in place, and many of the engineering firms are using terrestrial LiDAR versus an engineer visually assessing a field, just because of the fact that the engineer's visual assessment might be skewed, or he might not see what the scanner can do in that at that particular moment. So all the subjectivity is taken away while you're doing the visual while you're doing the assessment through the scanner. And again, there is the benefit of getting the scan back and reassessing it and doing it from a multiple dimensions. You might be hindered by time in terms of doing a visual assessment, but if you do it visually and then come back and recheck it back into the office setting, it's always an extra benefit. So many of the companies, engineering firms are making it as an SOP to use terrestrial LiDAR scanners besides their visual assessments.
Okay, thank you, Javed. Do you know of a regulator that will accept LiDAR scans and completed outputs in the place of as-built submissions on construction designs? Is this applicable and realistic in your opinion?
I don't know a regulator that would accept it. I haven't heard about that. Realistically speaking, it depends on how you have processed the data and how close you are making your final outputs to the way the regulator requires it for. It needs some work there, but I believe it has the potential to produce all of those outputs the way the regulator would accept it. And again, it depends on the trial. Someone has to go forward and produce outputs that are acceptable or up to a level or CAD design level that that the regulator would require.
Great, thank you, Javed. Just to let everybody know, it's just about 1:50 now. We're going to go right to the 2 o'clock mark. So we do have 1 or 2 more questions that have been submitted, so we'll get to those. But if anybody has anything else they want to ask, we do have about 10 more minutes. So yeah, the next question. There is a requirement to perform a vegetation assessment on the fire breaks on the site. Can LiDAR be used to fulfill this requirement?
It's a good question. Again, the LiDAR, the terrestrial LiDAR, if you're more specific here, if you're talking about the aerial LiDAR, yes, for sure, no doubt about that. But if you are talking about the terrestrial LiDAR, there are limitations in terms of fire breaks. Usually those fire breaks are not at a very small scale. They are into hundreds of meters of length. So for terrestrial LiDAR, I would say it's technically possible, but operationally not possible or operationally not feasible. Versus the aerial LiDAR, most definitely it can be used.
All right, thanks, Javed. I thought we had 2 questions, but the second question that came in was actually just an add-on to this question, and you responded. So it was asking what would be better, aerial or terrestrial, and you've answered that question. So that is
one thing
actually,
I would like to add.
Oh, sure, go ahead.
Daniel, sorry about that. One thing I would like to add here, it's I would ask the participants to look forward who are interested in the aerial business, in the drones and the LiDAR, is to look forward for the drones which carry the true LiDAR, and it's coming up pretty fast. So probably if you are doing any of the fire break assessments, if you take it aerial and do it through a true LiDAR, that will give you the most value.
Great, thank you, Javed. So that is all the questions we have. I guess we can end a little bit early today. If anybody does have questions or you think of questions afterwards, you can email info@awccc.ca and we'll add those questions to the transcript when it's distributed to everybody. But on that note, we will also be distributing a transcript of the Q&A to all attendees of this webinar, as well as we will post a video recording of the webinar to the GoToWebinar page, as well as on the awccc.ca webpage, which we are currently working on getting up and running. So with that, I'd like to thank today's presenter, Javed Iqbal. Thank you to everybody who attended the webinar, and we hope that you will join us for some other presentations over the next few weeks. Our next webinar in the series will be taking place next Tuesday, May 19th, where we will have Mike Hunka giving an overview of Alberta Watercourse crossing regulations. So if you enjoyed this webinar, I encourage you to have a look at the other webinars scheduled as part of this series on our GoToWebinar page or at awccc.ca and register for some of those other presentations as well. So thank you again to Javed for presenting to us today, and I hope to see all of you attending some of our future webinars. Stay safe and have a great day.